We're starting with geometry, and we're going to look at angles at the point. But just some interesting information is that this has been around for many years. About 2,300 years before or ago, a Greek called Euclid wrote 13 books called Elements, and in those books he contained more than 465 theories on what we are doing today. So it's a pretty old thing, but it's very important in a lot of problem-solving questions. So please take note of the following. When you have two lines intersect the point, the first thing that is very important is how do we name that angle. So I want to refer to this angle B. So I'm looking at this angle B. So if I want to talk about this angle, and you're not allowed to talk in exam, so if you need to explain that you are referring to this angle, there's quite a few number of ways that you can do it. It's not only about you doing it, but if the question refers to this angle, you need to know what they're talking about. The first way to say angle B is to start at one of the points and then work past that point. So I'm going to say angle. The first way is to say angle, and we indicate it with an angle like that. A, B, C. Angle A, B, C. We'll refer to that. Start with angle A, then go to B, and then go C. It means that angle B is the angle I'm talking about. You can also work from the other side. So this is also the same as angle C, B, A. Start at C, go to B, go to A. You can also talk about angle B. The only thing that you have to be careful of if you do this is if there is something like, let's say, that, and we say this is B, that you then can't say angle B because there's two angles. What you can do in that case is you can say this is 1 and 2 and then refer to angle B1 or angle B2 if you want to use this method. The third method is angle A, B, C, but instead of using the angle there, we put the little angle above. Okay, so it's angle ABC, or the last one is when you talk about angle B. When you say angle B, you have to indicate angle B in there, like that. And then only we know you're talking about that. You don't only use small b, because usually in triangles, the small b is the side opposite b. So there must be a degree there if you're talking about b degrees. Now, we can get all different type of angles, and when we classify angles, we look at what size they are. So we give them all names. The first angle that you need to know about is the acute angle, and you know all of this. Acute angle, you get between 0 and 90 degrees. Okay, so anything smaller than 90 degrees is acute angle. It is such an acute angle. Okay, the second one is a right angle. So when this goes up, it becomes a right angle, and the right angle is when it's not wrong. So right angle is 90 degrees exactly, and it looks like this when it's 90 degrees. Now in geometry, whenever you make a statement, you always have to give a reason. And to talk about right angle, this is also the reason or the code that we know that we use to refer to right angle. The next one is if I go past 90 now, we will call that an obtuse angle. Obtuse, larger than. Obtuse is an angle between 90 degrees and 180 degrees. So an angle that's between anything past that point and that point. So anywhere here, that will give us an obtuse angle. Our Next one is a straight angle. I'm just going to go next so that we can have space to write. So I'm going to say this is a straight angle. A straight angle is when it's exactly 180 degrees. So that will be 180 degrees. Then if we go past that angle, so all the way past that angle will give us a reflex angle. Reflex angle is an angle that goes from there all the way around, past there, so past there, anywhere from there to there. So anywhere there will be a reflex angle. So that's angle between 180 and 360 degrees will be a reflex angle. And if I made a full going from there and I go straight around all the way there, we call it a revolution. A revolution, which is one complete turnaround, and that is 360 degrees. So that is how we write, or that's how we talk about the angles when we look at the angles at the point. Now, when I have at a certain point, we have special pairs of angles. And we are looking when two lines intersect. So if I have two lines that intercept, because looking at angles at a point. So if I have lines that intercept, a few things can happen. First one is, let's draw a sketch. As you can see, I'm using a ruler, which means that those two lines are both straight lines. And let's put another angle in there. Okay, we indicate this as 90 degrees. I'm going to call this angle B. I'm going to call this angle A. I'm going to call this angle D. I'm going to call this angle C. So around this, we got special angles. Right, the first one that we need to know about is complementary angles. So complementary angles is angles that are nice to each other. They give each other complements. No, not really. Complementary angles, it is complement, not with an I. Complementary angles. What the complementary angle does, complementary angles add up to 90, sum to 90. So they add to 90 degrees. So in this case, what adds up to 90 degrees? Well, if this straight line here, if this is a straight line, and this part is 90 degrees, then A and B must add up to 90 degrees. So I will say complementary angles here, A plus B equals 90 degrees. What is my reason? Now, when I indicate, as I said, if you make a statement in geometry, then we need to give a reason. And the reason for complementary angles, or the way to show complementary angles, will be is this. So I show complementary angles, and the reason I'm going to put the big reason over here. Complementary angles look like this, line in the middle. So I say A plus B equals 90 degrees. What gives you the reason to say so? This is the reason. If you do not have the reason that you are saying this, your answer will be wrong. Our next one will be supplementary angles. Now, supplementary means add up to supplementary. It adds up to 180 degrees. Supplementary angles add up to 180 degrees. The big reason for that, or the code that we're going to use to do this, looks like this. It is a straight line showing that the two angles add up to 180. So that's the code that we'll use for supplementary angles. So what here is supplementary? Well, we've got a couple of supplementary angles. If this is a straight line, all right, then A and D needs to add up to 180. So I'll say A plus D supplementary There's a straight line there, so D and C adds up to 80. D plus C adds up to 180, so they are both supplementary angles. C plus B plus 90 is also supplementary. But if I only look at pairs, then AD equals to 180 and DC equals 180. The last thing that we need to know about the angles is the vertical opposite. I'm just going to move this a little bit up. So vertical opposite angles. Now what vertical opposite angles are is, if I look at my sketch over here, if I have two lines intersecting, then the two angles that are opposite each other must be the same size. A must equal C. And the reason for that is, if I can quickly show you, if that is a straight line, then A and D is 180, and D and C is 180, which means A and C must be the same. If I look at this, what I write here, if A and D is 180 and D and C is 180, then A and C must be the same because D is the same. So A and C doesn't add up to 80, but A and C together must be the same because D is the same. How do I indicate vertical opposite angles? The code for that, the sign that we're going to use for that, looks like this. And that's the code, the Angry Bird code. Okay, so vertical opposite looks like this. And if I had to look at my sketch, I can say A equals C. What is the reason saying that? I do that. What is my code here? I say A plus D is 180. What tells me that? That's the code. That is the code. So every time you make a statement, you use a code. These are the codes that you need to remember. I'm going to circle them in red. Vertical opposite, supplementary, complementary. What we also need to remember is the supplementary angle. We need to know, yep, that's that, the revolution. That's basically all that you have to remember. Please look at the following video on the compass bearing. That is pretty important, but this video is already too long.